Good morning. Today we will correct together your homework about height. So please put your homeworks in front of you and follow with me. Number one, given the following figures, here we have a triangle ABC. In the triangle we have a given, I'm just reading the figure, BE perpendicular to AC. So BE is the height relative to AC and E is the foot of perpendicular. Now, if we want to draw the height issued from C perpendicular to the opposite side, which is AB, I can't draw it here. So it's not perpendicular. The only choice is to elongate AB and draw CF perpendicular to the line AB. And this is the case of obtuse triangle in which we find the perpendicular or the foot of perpendicular outside the triangle. Okay? The last one, I have to draw the height issued from A relative to BC. Since I can't draw a perpendicular that's inside the triangle, simply I have to elongate it. And now AD is perpendicular to BC and AD is the height relative to BC. Now, what's the point of intersection of these three heights? Look, if I elongate AD and BE and CF, they will intersect at a given point which is O. So the intersection of height is the orthocenter. O is the orthocenter, and since our triangle ABC is an obtuse triangle, then it's the only case where I can find that orthocenter is outside the triangle. Okay, that's how I read or understand the figure. Now let's read the sentences together and complete. ABC is an triangle. What's the type of the triangle? Here, BAC is an acute angle. CBA is also an acute angle. ABC is an obtuse angle. Since it has an obtuse angle, so directly I can say that ABC is an obtuse triangle. Now, since it's perpendicular to AC, this is AC. Which segment or line or semiline or whatever is perpendicular to AC? Here we have the perpendicular BE. Then I can say that BE is the height relative to AC. Now, AD is a height relative to DC since or BC, the same. It's the height relative to BC since AD is perpendicular to the line BC. It's a semiline issued from the vertex A perpendicular to the opposite side, which is BC. Now, since CF, this is CF, it's perpendicular to what? It's perpendicular to line AB. Then CF is a height relative to AB. Okay? Now, AD, BE, and CF are three heights. They intersect at a point O, which is called the orthocenter, and the orthocenter here is outside the triangle. Okay, this is our triangle ABC, and this point is outside the triangle. Number 2. Draw a triangle MNP such that MN equal 4 cm, MP equal 5, and MP equal 3. When we have the case of three sides, then I have to use my compass. Okay, first of all, start by drawing a side. Here, for example, MN equal 4 cm. Then open your compass of radius 3 cm and draw an arc. You will get here an arc, and similarly MN. So from the vertex N, open the compass of NP. Open the compass of radius 5 cm put it the vertex at N and draw another arc. The point of intersection of these two arcs is point P. Here we have MN equal to 4 centimeter, NP equal to 5, and MP equal to 3. Now, draw the height. If you look well, it's a right triangle. Now, draw the height ML relative to NP. So it's from vertex M perpendicular to NP. How do I draw it? By using my set square. Put one of its edges on PN and join. Draw here by joining the vertex. Now this is ML. It's perpendicular to PN, so ML is the height relative to PN or MP. Now find the distance from N to MP. From N to MP, we know that to draw the distance or to measure the distance, I have to deal with the perpendicular. And here, since NM is perpendicular to MP, so I checked it here by using our set square, I can clearly say that the distance from N to MP is MN, which is 4 centimeter. Now, what does MN represent to the triangle MNP? This is MN, which is perpendicular to MP. So I'm talking about what? It's the height relative to MP. Find the distance from P to MN. Again, to find the distance or to draw the distance, I have to deal with the perpendicular. Here I have that PM is perpendicular to MN. So to find the distance from P to MN, I have to look what's the length of PM, which is 3 centimeter. Last part, what does MP represent to MN? Look, MP is perpendicular to MN, so simply I can say that PM is the height relative to MN. Okay? Here we should note that since PMN is a right triangle, this is the first height PM, the second height LM, and the third height NM. They intersect at which point? At point M. So M is the intersection of the height, so M is the orthocenter. But here angle PMN equal to 90 degrees. So what should I understand and memorize well? In a right triangle, the orthocenter lies on the vertex of the right angle. Okay, we can follow this rule, and when we find a right triangle and we have to find where is the orthocenter, I can directly say it's the vertex of the right angle. Now I have to complete. What do I call L? As we said, ML is the height relative to PN. So L is the foot of the perpendicular. Now since PM perpendicular to MN, then PM is the height relative to MN. Since MN perpendicular to MP, so I can say that MN is the height relative to MP. Now the three heights intersect at one given point, which is M, and that's why I can say that M is the orthocenter. It's the point of intersection of the three heights. Please, you have to correct your mistakes if you find mistakes in your homework. Thank you for your attention.